Everyone pay attention or no? Okay, today we are discussing the last topic, is this topic, inequality and system of inequality in 2 dimensions. And we spent next day, the third day, and this Thursday, and next Tuesday to do this package. Okay, we have time. Slow down. I suppose nobody be absent because it's super important. And the test is easy. It's very, very similar to the review packet. Both the tests contain, hey, putting off microphone.
Professor, quick question.
Wait,
you want us to turn in the package as well?
Okay, no, not today. Today, no. Today we discuss.
No. What?
Uh-huh.
When it's, you want us to do the review package and then later on turn it in, sir?
No. The review packet, no. The review packet is the guide, the study guide. If we discussing here one by one, you don't need to turn it to me, never. No. You, to say now, I suppose next Tuesday, I will send the test number 2 on paper. And you send me back according to the calendar. Let me see the syllabus. Okay, what is second? I have the syllabus here at 11:40. The official day of the test number 2 will be October 22nd, no? October 22nd. So we spent, today is 13. Putting off the microphone, off. Let me see. No, I know. Quintana Thompson. Okay. Today is 13. Today, the topic today is system of inequality, no? Inequality. Okay, in 2D. We spent 15, October 15 is this third day. And next Tuesday, October 20, to do. And October 22nd is the test number 2. Entonces, depende. Si I finish or no the review, we continue October 22nd. Entonces, I will send October 22nd the test number 2, and you resend to me October 24. So October 24 is the due date for the test number 2. And also online. Okay? Online, both. Include the homework. Remember, the homework is optional, but you have reward if you complete the homework 80%. Any homework 80, you have 10 points extra in the test. Everything is clear? Confusing? Okay, clear. Okay. Do you see the board? Yes or no? Come on, I need communication. Do you see the board?
Yes, Professor. Yes, sir. The board's up.
Yeah. Okay. So we start. This is easy. Maybe you see before in your life. Let's start example 1. Hey, off microphone. Hey, off microphone. Let me see who opened the microphone. Okay. Example 1. Example 1 is, suppose 3x minus 2y less than 6. So the solution, this is the inequality that contains 2 variables, x and y. The solution is no one interval, no, it's one region on the rectangular coordinate plane. So the answer of that part is just graphic. You are doing the graphic. Of course, we are doing by hand and verification with the decimals, as always, no? Okay, so what is my first step? My first step always is solve for y. Now we have 2 variables. X is independent variable, Y is dependent variable. And you take the original inequality always and solve for Y. Let me try. So it says minus 2Y less than minus 3X. I move 3X to the right-hand side plus 6. Now divided by negative 2 because I want to solve for Y. So I isolate the Y. And you have Y alone, but what happened with this sign? It's reversed. Yes or no? Because you are dividing by negative number. When you are dividing by positive number, no. Stay the same. But when you are divided by negative or multiply, depending on the problem, so it's 3x, 3 over 2x minus 3. Okay, and this is my new inequality. Expressed in another way, but it's equivalent to the original. It's the same. It's the same. But this is more clear to understand. Now, after that, you write the one thing is called related equation, no inequality anymore. The temporary, to understand the problem, I remove this symbol by equal. Because for me it's easy, or relatively easy, do the graph of the line here, right? Remember the graph is y equal mx plus b. You're super familiar with this idea. Therefore, b is negative 3. Therefore, the y-intercept is the point 0, negative 3. I plot that point here. And using the slope, in this case, the slope is 3 over 2. Look at that. Slope m is 3 over 2. I know by definition that slope is the ratio between wrong and rise. Therefore, wrong is 2. Rise is 3, positive 3. From the given point get plot, you go up 3 units, 1, 2, 3, and 2 to the right, 1, 2. I plot the second point, and we have 2 points. And with 2 points, we can perfectly do the line. In this case, we are doing the line, but in this case, we are doing dotted line. This is the convention, guys. Convention. You need to be aware for the convention. Agree with me. When it's dotted line, when it's solid line. Okay, it's dotted line. In this case, let's see. Wait a second. What? Let me move in that direction. Good, very good. Dotted line. Why dotted line? It's dotted line because my original inequality do not contain equal sign. So my original inequality is a strict inequality. Look, we have no equal sign here. No equal sign, dotted line. Equal sign, solid line. So we have two possibilities. When it's less than or greater than without equal sign is dotted line. When it's less than or equal to or greater than or equal to solid line. Good, super. Okay. Now, this line, the only thing we are doing is split the plane into semi-plane. And the solution maybe is the semi-plane up or the semi-plane down. So to understand this, there are two possibilities. You go not exactly to the original inequality, to the new one. This is the original number 1. This is the new one, number 2. It's the same, right? When the y is isolated. And this symbol, when it's greater than, indicate that the solution is above the line. So you shade or highlight the solution like that. Okay, entonces es very, very important to understand que when it's greater than is above the line, when it's less than is below the line. It's a one way, but sometimes it's not exactly like that because suppose that we have vertical line. Entonces es no above, below, es right, left. Entonces another way to visualize what region you shape is using testing point. Testing point. The typical testing point que es easy is 0,0 at the origin. I need to investigate if the origin belongs to the solution or no. In this case, of course, belong to the solution, but I have no idea. So use substitution x and y, in this case, 0 both in the original inequality. 3 times 0 minus 2 times 0 should be less than 6. 3 times 0 is 0. 2 times 0 is 0. This is 0, less than 6. And this statement is true. Therefore, the origin, que es 0,0, belongs to the solution, and our solution region is the semi-plane above the line. Any question? What part you don't understand very well? Super clear? No? Sí? Yes? No?
Sí, clear.
Okay. Do you want to see in Desmos?
Sure.
Sure.
Always.
Okay, let me switch it to Desmos. Switch into Desmos. I prepare for you this piece of Desmos que contains several examples. Example 1, example 2, example 3, example 4, example 5. Okay, look at that. You put equation. Look, 3x minus 2y. The equation also the inequality. And you put available. And automatically Desmos shape the region above the line, and also include dotted line in the boundary que separate solution and non-solution. No? Any question, guys? Easy. It's important that you understand very well because I want to complicate this. This is the first example, elementary kindergarten example. But I want to complicate more, and more. Any question? No. Okay. Let me switch into the board now. Okay. Now the second example is also easy. The second example is also easy. Look, is example 2. This is non-linear. Example 2. Let's do it by hand and after verification with the decimal. Suppose x squared plus y squared less than or equal 4. Non-linear. Entonces immediately I convert the inequality to equation, a related equation. So in my mind, I copy x squared plus y squared equal 4, temporary, because this allows me to create the curve que separate the solution and no solution. No? It's the boundary. And you recognize what kind of curve it is? This is what? It's a line? No, line no, because it's non-linear. Exponent 2. Do you recognize it's a circle? Yes or no? Yes or no?
Yes, sir.
Yes, it's a circle. Okay. By the way, where is located the center of that circle? Center. I don't hear anything. Center. It's located where? Center.
0, 0.
0, 0. Very well. And what about radio? What is the radio? What is the radio?
No sé.
No sé. Es tú. Where come from that 2? Square root 4. Okay, remember. The formula of the general, the circle is x minus h square plus parenthesis y minus k square equal r square. In this case, h and k are 0 because my equation is x squared plus y squared. No h, no k, that means it's 0, 0. This is h, this is k, the center. The center, this is center. And the radio, you take the number in the right-hand side, get 4 in our example, and r squared is equal 4. Therefore, the little r is 2. So the center is here, 2 in any direction, like that, like that, like that, and like that. And we are doing the curve. What kind of curve? Solid or dotted?
Solid.
Solid, very well, because equal sign indicates solid. I tried to do my best skill doing the circle. Was not good circle, but I tried. And U-shape, what part U-shape? Because we have two regions, outside the circle or inside the circle?
Inside.
Inside. How do you know it's inside?
Because it's less than.
Because it's less than. Very well. Any question? Suppose complementary. Example 3 is the same equation. For now, I copy like that. X squared plus y squared greater than 4. What is the only difference between this and this?
It doesn't have equals, and it should be outside the circle and dotted line.
Eso. Watch. It's dotted line. And you shape. Let me erase everything. And the example 3 is the same circle, the boundary, but that boundary is dotted line. And the solution is the region outside the circle. Something like that. Okay, look like a zone. Everyone understand very well this or no? Good or no? Good or bad? Good or bad?
I'm good. I don't know about anybody else.
Good.
Good, good. You interrupt me any problem, guys. Let me check it quickly in Desmos. Example 2 and example 3. Okay. Example 2 and example 3. Do you see Desmos now or no? This was
Yes,
the example 1. Now look at that example 2. Example 2 is this inequality. And this is the answer. Look. Wow, it's a circle. Center in 0,0, radio 2 in every direction. And you shape inside, and the boundary in between solution and no solution is solid line. That means it's equal. That means the boundary belongs to the solution set. However, in this third example, it's different. And the answer is like that. Okay, let me erase the example 2. Look, dotted line outside the circle. Any question? Any question? Super easy, eh?
no problem.
No problem. Okay. Okay, I want to complicate more this because you are smart students. Okay. 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 The board, no? Okay, example 4. Well, in example 4, I bring new situation. I bring system. Not only one inequality. No, 2 inequality, 3 inequality. I don't know the amount of inequality I want. Let me start for 2. Okay, suppose this system gets y less than or equal 1/2 x plus 2. And this is the inequality number 1, no? And we have another case, 3x minus y less than 3. Inequality number 2, and this is the system of inequality. And the solution is always graphical. You're doing the graphic of the inequality. Let me try. By hand and just in case using decimal after. Okay. Okay, remember, always, don't forget, isolate the y. But in my first inequality, y is already isolated. Good, I like that. Immediately, I convert to equation. Okay, actually, this is not the same problem, but it's my auxiliary related equation que help me to create the partition in the plane, no? Plus 2. I can see, remember, y equal mx is linear. B is 2. So y in the set is 2 is 0,2, no? Y in the set of this line is 0,2. And the slope is 1/2. Therefore, wrong is 2. Rise is 1. And what is 1 is positive? It is positive, so 1 up and 2 to the right. Rise from 2 to 3. Wrong from 3 to 0,3 to 2,3. Now I am ready to do the sketch, so do the line. What kind of line are you using? What kind of line? Solid or dotted? What kind?
It's solid.
It's solid. It's solid. Very well. If you want, you put an arrow here to indicate that this line continues forever in that direction. In that direction. Now, this is a moment to shape. Entonces, I go to the symbol. This symbol is less than or equal. Entonces, you shape above the line or below? Above, below. Come on.
Below.
Below, because less than is below.
Less than is below.
Less than is below. I shape. Because the final answer, I put it using the highlight in blue color, in yellow color. This is the only the solution for the first. The solution for the second. The second is not already isolated y. So I have to isolate the y. I copy negative y less than minus 3x plus 3. Entonces you divide it by -1, I suppose, no? Because I want to isolate y alone. Entonces y is greater than, you remember when you divide by negative 3 divided by -1 is 3x minus 3. And the line is 3x minus 3. Entonces, likewise, the y in a set is the point 0,3. I plot that here. And the slope is 3 over 1 because it's a whole number. Therefore, I suppose that wrong is 1, right is 3. Wrong is 1, right is 3. So from this point, 3 up here and 1 here. I got it, that point. I do the line, using my rule. Okay, but what kind of line? Dotted or solid? It's bigger, slow. It's 3, it's slow.
It's dotted.
It's dotted. It's dotted. Very well. It's dotted in that case. Okay. Now, I don't know why I like to put the arrow to indicate it's a line, and the line is infinity, no, in both directions. So, and what region I shape? I shape below this line or above this line? Look at that symbol. Greater than. It's above, right?
Yes.
It's above. In green color. In green color. Okay. And what is the solution? What is the intersection? Blue and green. When I suppose using my imagination, guess that part. And this is the answer. Super? Super clear?
Yes.
Uh-huh. Now,
Yes, sir.
you see this
Sir.
one, huh? Question. Come on, question. No
Not
question?
right now.
Okay.
No question, sir.
Okay, no problem. Let me check in just in case and Desmond CD okay or no. Switching to Desmond. Desmond. Okay. Now, this is Desmond, no? But this was example 3. And this was example 2. Now example 4. Example 4 is 2 line. Look at the line. And example 4 look like that. Okay, recommendation. When you are doing in Desmos, I recommend that you using the same color. In this case, I using green, or red, or blue. You can see another example, a different color, but the same color. Entonces, the part que overlap two regions is obvious que es the part que is a little bit more darkness here, que es the overlap. Okay, this is the solution. Okay, look at that. Suppose que I delete this inequality. Oh, suppose que I delete this inequality. Oh, and both together is this. The solution is the part que you see que is a little bit bold color, no? It's a little bit more obscure color. No? Okay, super. Very good or very bad?
Yes, sir. Good.
Yes. One more of the piece okay problem. One more of the piece okay problem. Let me try another. That was example 4, no? 4, yeah, that was example 4. Now example 5 is the last of the easier. Okay, suppose example 5 now. Example 5 is bring me new situation, because we have several inequality. This is inequality number 1, non-linear, okay. We have another inequality that is x minus y greater than or equal minus 2. Inequality number 2, linear. In this case, this is linear. And y greater than negative 5. It's also linear. So we have 2.
You're still in decimal, sir.
Yeah, of course. But let's practice. Entonces, the super complicated problem that we are doing after that, we are doing only using decimal. Okay?
Okay.
Okay. Remember, the answer that you send me in the test, you are doing by hand. Okay? And, well, not necessarily by hand, guys, because you can use in decimals. I don't remember if I explained to you how you download the image in decimal. One possibility, or you print out and you printer, and you scan and you send me that. Okay, any possibility. What do you consider is the best way? Print or download the image, because demo allow you download the image. Okay, you take one by one inequality. The first inequality, y is already isolated. Ooh, nice. I take advantage of this. I don't know so you are familiar with the transformation for the function in Euclid algebra, but this is a parabola. This is a Get in mind? Okay, take a picture, okay. This is the parabola. Look, normally I know by memory, okay, one parabola like that is y equal x squared.
Sorry, I can't see what you're doing because you're still on in decimals on number 4.
Sorry. I am too fast. Switching more. Much better now?
Mucho better.
Mucho bueno. Okay, copy is a system that contains 3 inequalities. The first one is non-linear, and the second one and the third is linear. It's a line. So I try to explain that the first one, when I change two equations, it's a parabola, no? But it's a parabola, we have some transformation because we have minus. When you have a minus, a reflection. Reflection about the x-axis. This is the y equal minus x squared. I suppose you remember this in color algebra. Plus 4 is a vertical shift 4 units up. 1, 2, 3, and 4. Actually, my parabola look like that. That 4 indicate the y-intercept. The y-intercept is 0.4. Look here. I plot that point. And this parabola up and down. It's supposed to be passing through positive 2 and negative 2 because the x-intercept, you put y equal to 0, so there's minus x squared plus 4 equal to 0, and you solve for x, ¿no? Entonces, x squared equal minus 4 divided by negative 1 both sides, x squared equal 4, apply square root both sides, x is equal plus or minus 2. So you have 2 points, it's 2,0 and negative 2,0. You know very well this. So this is a parabola, up and down, y-intercept is 0,4, and x-intercept is 2,0, negative 2,0. And we are doing the parabola. Let me try to do my best parabola. This parabola is solid or is dotted? Is solid or is dotted? Dotted line.
It's solid.
It's solid. It's solid, and the reason it's solid is because you can see this equal sign. Okay? Let me try to do my best. No good. Okay. And this is above the parabola or below the parabola? Above or below? According to that symbol. It's below or above? Below. Less than below. So this is the solution for my first inequality. Boom. Blue curve. The solution for my second inequality is easy because it's linear, no? Linear is easy. Let me try linear. This erase is no good for me.
Okay, before you, oh, never mind.
Oh, sorry. Because you want I do not erase? Eh? Joyce?
Yeah, can you go back just a little?
I did that.
I'm not understanding how you got the -4. When you divided by -1 on both sides, you changed the 4 to -4 so that you got a +4. But why did you change it to -4?
Well, the reason was because I want to isolate x squared. But we have this equation. Minus x squared plus 4 equal to 0. There are many ways for solving this. Well, the thing is, you move 4 to the right-hand side, no? Maybe.
Oh, okay. Now I get you. I got you. Never mind. My brain just totally missed that spot. Okay, never mind. I got it.
Okay.
I got it.
Let's do now the second inequality. The second inequality is, let me copy, x minus y greater than or equal -2. Well, this second inequality, I need to solve for y. Minus y greater than or equal -x -2, no? Divided by -1. everything. We have then y less than or equal. I reverse this sign, x plus 2. I convert to equation because I want to make a line to separate the plane, and I can see that y-intercept is 0,2 positive here. I can see the slope is 1, so it says 1, 1 here. I do the line. What kind of line? Solid again, no? I want to use a black color. This is my line, without rule, directly. Yeah, I shade, in what direction I shade? I shade, look at that. Below. Do you understand it below? Because in the middle of the process, I need to reverse the sign because I divide by -1. So say below. Black hole below. Now, the last black hole. The last inequality is super easy because it's horizontal line. Horizontal line -5. In this case, dotted line because no equal. Entonces, let me use in green color. -5 here, look. Entonces, -5. And this is above, no? So es that part in green color. Wow, it's confusing, eh? Very confusing. Bueno, let me try to use in the highlight and make it zoom. Is inside the parabola, below this line and above the other line. I suppose using my imagination, que es something like that. Yes or no? Yes, make sense? Let me highlight the color. This boundary below, yellow, yellow, yellow. This boundary is also yellow. This boundary is also yellow, solid yellow, but this no. This is dotted yellow. Any question? Wow, confusing. When you have more than 3 or 4 inequality, it's very, very confusing. And so I highly recommend using decimals. I want to show you this in decimal, no? But the next example is more complicated. Definitely, we are using decimal. Giovanni, putting off the microphone. Okay. Giovanni, okay, no problem.
Problems with the mic. I'm having problems with the mic. It keeps going on and off. I'm sorry.
Okay. Do you see that? Let me make it zoom. Do you see the entire problem? Oh, wow. It's okay. Wow, what the hell? Okay. Look, do you see the problem now? Let's switch it to decimals to see the problem number 5 in decimals. Okay. Number 5 in decimals. Okay, there you go. Okay. Problem number 5 in decimals. Look, we have parabola. Okay, up and down. We have a line. We have another line. Look at that. I put in red color. The solution is this region. Is inside the parabola, pero is below this line and above this line. So what is the coincidence? Inside the parabola, below this line and above this line, well, is this region. Let me try to travel for the boundary using the course of the mouse. There you go. Final answer. This is dotted. This is solid. Any question? So you have no question. We are ready to solving super complicated problem. Super complicated problem. I want to copy on the board and let's play this game. You have to practice. Play this game. You open the Desmos, you own Desmos. You create account or not yet in Desmos?
I haven't.
You have account?
Yeah.
Super. Open Desmos. Everyone, open Desmos and follow me. Easy, super easy. For example, let's do it complicated, very, very complicated. No, the first one is not super complicated, but okay, suppose the collection for the complicated example. Example one complicated is 3x minus 6y less than or equal to 12, inequality number one, 2x minus y greater than 4, inequality number two. This is the system. I need to plot both using Desmos, and try to find solution. Solution region. We need to find. Copy the inequality and try. Let me see my Desmos. Okay. Look at that. Okay, ready. Okay. Did you copy the equation or not yet? Did you copy or not? Okay, let me try. Switch it to the board again. Board. Okay. Do you see the board, right? The copy? Time to copy. Now, immediately in your laptop or computer, you try to find the solution of this. That's more fantastic because you don't need to isolate y. No. You write anyway. You write in explicit or implicit. No. You don't need to isolate the y. No. You copy exactly like it's given for you, and that's it. And you get the solution in this. Let me show you my solution. My solution. Let me see my solution. My solution is, okay, switching to the Desmos. Wow. No good. Okay. Desmos. Switching. Desmos. Do you see Desmos? So you copy something like that. Look, 3x minus 6y less than or equal to 12. I highly recommend using the keyboard for Desmos here. Okay, this symbol less than or equal, look, less than or equal, greater than or equal, greater than, less than or equal. You have arithmetic symbol. And also, okay, look, remember using the same color. In this case, I use in black color. Both inequality and black color. When you see black color, you see that the solution is the super black, bold color. And the intersecting point, this is a curiosity, is 4/3, negative 4/3. Let me know so you get the same solution like me. Come on, in your own laptop.
Yes, sir, I did.
Okay. All right, raise your hand. I want to see your hand. This is my hand.
I'm good.
Okay. All right, raise your hand, the people who get the same answer like me. Only Joyce. Who more? Giovanni. Who more? Nobody. Vanessa Ballesteros. Who more? Thompson, no. Ernesto, Cabeza, no. Joseph, no. Bianca, no. Jeremiah, no. Sebastián, no. Come on. Yes or no?
Yes.
Hello, Professor. I don't understand anything. It's a crazy online. Yes. Jeremiah say yes. Bianca. Okay. Let me project it again, Desmos. And this is super important. Very well. And it's super important. We're using the same color. Using the same color. For the inequality, using the same colors. You make a decision, black. You make a decision, blue. Same color. So the part can overlap. This region is the solution. And you see que it's a little bit more bold color. Good or no good? Putting off microphone.
She moved it over.
So I suppose that everyone get the answer or not yet?
Your name?
Ashley Torres? Ashley, are you there? Ashley Torres. Christian left. Why? Ashley, are you there? Ashley Torres. Are you sick? Giovanni, putting off microphone. Okay. Let's move on to the second example. Let's move on to the second example. Suppose the second example.
I was drinking water, Professor. Sorry, I didn't know the mic was on again. It keeps doing this. I'm sorry. I don't know why.
Okay. Let's move on to the second example. The second example, I switch into the board now. Okay. The second example is, let's do at least 3 examples using decimals. Example 2. Example 2 is out. Board. Board. Okay. Switch it to the board. Okay. There you go. Example 2. Example 2 is 3x plus y less than or equal 6. Inequality number 1. 2x minus y less than or equal to -1. Inequality number 2. X greater than -2. Inequality number 3. And number 4. We have 4 inequalities. And we have, for example, y less than +4. Okay, this is the system que contain 1, 2, 3, 4 inequality. This is -2, guys. -2. -2. Come on, try. You put 1 by 1 the inequality in your decimals. Try to put in the same color. I'm using, I don't know why using black color, but no, you select the color that you prefer. Okay. Let's select black. Pero no necessarily black. 3x plus y less than or equal 6. 2x minus y less than or equal to -1. X greater than -2. And y. The problem is try to understand the region. Try to understand the region. Let me try. Let me try to understand the region. Oh. Okay. There you go. Okay. This is my decimals. Do you see decimals? Make it zoom. Look, let me try. This is, okay, I make a zoom. Okay, I copy, look at that. I copy My first inequality, my second, my third, my fourth inequality. Y I copy some point que es the connection. But basically, my solution is formed by this polygon. Look at that. One vertex is located in negative 2,4. Another vertex is located in 2/3, 4. This is in decimal, but in fraction is 2/3, 4. Another vertex is 1,3. And another vertex, last one is negative 2, negative 3. The solution is, look, let me show you. I eliminate the first inequality, the second, third. Okay. We have no inequality, only the first one. The second, the third, bounded to the right, and the last one bounded downward. This is my region. Pam, pam, pam. Do you see I move the cursor of the mouse? Cum, cum, cum. Ese polígono, ¿no? Este cuadrilateral, ¿no? Es 1, 2, 3, and 4 side. Cuadrilateral, ese polígono. Any question?
No, sir.
Okay. Well, entonces I try to do one more. Okay, consider it interesting. I skip number 3. Let's go to the number 5. I guess interesting. Okay, let me try. Okay, number 5 is, look. Okay. Let me erase everything. Well, no, not everything. Let's do a number 5. And that's more I consider a number 5. Okay, is x minus 1 square plus y plus 1 square less than 25. Inequality number 1. The second is x minus 1, again, wow, plus y plus 1 is greater than or equal to 16. Two inequality, only two, but a very, very non-linear inequality. You will be able to recognize what kind of figure, what kind of curve is number 1 or number 2. Suppose like equation, x minus 1 square plus y plus 1 square equal 25. It's a circle, yes or no? It's a circle or no? It's a circle, yes or no?
Yes, that one's a circle.
The center. Where is located the center of this circle?
25.
No.
It's half. 12.
No.
No, 12.
H and K. Who is H? Who is K? Circle. X minus H square. Y minus K square equal R square. This is the standard form of the equation for the circle. The standard form. I suppose you remember college algebra. Entonces, H and K en our specific problem is H is 1 and K is negative.
25 is 5.
Okay, H
Center
is
is 1.
and K is negative 1. Do you see or no?
Yes, sir, we do.
And R, que es el radio, es 5. Y5, que es el square root 25. Es 5. And the other is exactly the same circle, no? And this circle, the same center, but the radio is 4. The solution is two circles, concentric circle, same center, 1, negative 1. One, the radio is 25, it's bigger. This is inside because it's less than inside. And this is outside. Come on, try in this one. And you let me know what look like that region. Look like something. You look like, I don't know. Look like one figure. Let's see. Wow. Okay, do you see Desmos? This is example 5. In example 5, we have two circles. Look. Boom. Do you see the solution? The solution look like a ring. Yes or no? Everyone get that solution or no? Nobody? What happened? What's going on? You are doing or no?
It looks good. It looks good. It looks good.
Microphone, Joyce. Good. Microphone. Joyce, you want to say something?
No, I said I see it.
Okay. I don't know how you hear you like that with the echo. Any other guy? Ernesto, Cabeza, Joseph, no? Bianca, Giovanna is okay. Sebastian, Jeremiah is okay, Professor. Bianca, no? I need to make sure everyone understand very well Desmos or no. Definitely no, Professor. No, I don't understand Desmos. This is very, very complicated for me. I never understand Desmos. You understand? Bianca, you understand? Yes or no? Say yes or no. Jose, yes or no?
I understand it. Thank you. Thank you.
I know que you understand. Ernesto. Okay. Sebastián dice que I understand. Okay. Cristian Leiva. Vanessa Ballesteros. Come on, guys, answer me. Yes, no, Professor. Yes. Who is that? This is DD. Okay. Okay. One more example. I want to go to another topic quickly. Quickly to another topic. Another example. Okay. 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 Last example, I promise, of this inequality part. Suppose it's a number 10. I call number 10 in Desmos. Is x greater than or equal to 0? Wow. Y greater than or equal to 0. Inequality number 1, inequality number 2. X plus y less than or equal to 4. Inequality number 3. And 6x plus 2y less than or equal to inequality number 4. This is the system to contain 4 inequalities. And you try to find solution. Solution is you are doing the solution one by one, and finally try to find the intersection of this. You copy the system? Okay, let me try to understand. Look.
Yes, sir. I copied.
Look, the first and the second represent, look. This is my rectangular coordinate system, x, y. X greater than 0 is that part. Y greater than 0 is that part. And both together represent the first quadrant, that part. This is considered only this and this. And the rest is linear. Let's see in decimals to do fast. Okay. It's a number 10. I suppose that you can see something like that.
That's exactly what I got.
Okay. Okay. Let me try to this region solution is represented by polygon. This polygon contains 1, 2, 3, and 4. It's a quadrilateral. It's a quadrilateral. But the vertex of this figure is 0,4, 1,3, 2,0, and 0,0. That's the origin. How you find that point? Easy. Is consider, if you consider this like equation, x plus 4 equal 4 and 6x plus 2y equal 12, you working the system of the equation in order to find the intersection. Okay, the solution is 1,3. Let me check it. 1 plus 3, look, 1 plus 3 is 4. And 1 times 6 is 6. Plus 2 times 3 is 12. Is 2 times 3 is 6. Is 6 plus 6 is 12. At this point, 1,3 represents the solution of this equation and this equation. The rest is just the corner. So the y in a z, the x in a z, and the origin. And represent the 1, 2, 3, and 4 vertex of this polygon. Any question? No? Okay.
Okay, can you repeat the points that you got?
This point, do you see this point? Look, I write here, look, 1,3. Look, I write 4 different points. 0,0, 0,4, 2,0.
Okay, I got 1,3.
1,3. 1,3 is the intersecting point between this line and this line. Okay, 1,3. Okay? Okay. Let me try, and the time we have is not too much, to introduce one new idea. One topic, it's the last one, que es the application. You see, bueno, professor, what is the application, that part? Let me try to explain the application. Application is, and one thing is called linear programming. Okay, application for the system inequality is linear programming. Is the branch of the mathematics que apply in this programming. And this look like a computer, no? Code, no. It's another thing. So basically, this is the typical problem of the optimization. Optimization. And any problem of the optimization contains always 2 parts. One part is the objective function. Objective function.
You still have that,
Okay. Now it's okay? Now it's okay?
Yes,
Yes.
sir. It's okay now. Let's see it.
Okay, let me start at the beginning. So the new topic is shortly we discussing is called linear programming. Let me make a zoom. Linear programming. And this is typical optimization problem. Optimization. Optimization in mathematics means that you try to find the best value. Suppose que in one problem you need to find the profit, that you maximize profit. Another problem, you find the cost and you minimize the cost. So it's optimization and find maximum or minimum. Depending on the problem, si es good, it's maximize, si es bad, it's minimize. So normally, the optimization problem contains two pieces. The first piece is called objective function. An objective function is equation, regular, is linear. That is the reason it's linear programming, linear. Suppose, normally, I don't know why it's called a capital Z. Capital Z is the variable that you want to optimize. So, and my problem, my goal is que the objective function to be maximum. The specification. So optimize or maximize this variable. I try to find the Z maximum in my problem. And we have another piece. This is my first piece, and my second piece in the linear programming problem is the constraints. The constraints. And the constraint always is a system of the inequality. And this is determined by the restriction of my problem. Restriction of the time, restriction of material. Suppose x greater than or equal 0, y greater than or equal 0, x plus y less than or equal 60, and y greater than or equal to x. Okay, the constraint is the system of inequality. We solve it exactly as we are doing before. Let me try by hand to solve this problem by hand. And after, well, we can see in decimal, no? Pero by hand. Okay, look. By hand is something like that. Okay. The first step is try to find the solution region of the constraint. Now you plot that. So x greater than 0 and y equals 0, both. This is my first quadrant. And my region is located here in my first quadrant. Let me highlight this color. But unfortunately, we have this equation, que is x plus y equals 60, no? Therefore, the x intercept is in 60,0. I suppose that this one is not 1, is 10, 20, 30, 40, 60. This is like that, 60,0. And y intercept is in 0,60. So this is 60, 60, 60. And my line look like that, 45 degree. 45 degree, 45, 45, 45. Pero 45 degree in opposite direction. Negative 45, no? 45 degree, 45, 45, 45 degree. Here. And this line is solid or is dotted? Is solid or is dotted?
Solid, sir.
It's solid. Now we have the last equation, the last inequality. And the last inequality is this one. Is y equal to x. I put temporarily like equal, no? And this is a line that passing through the origin because b is 0, no b, 0b. And its low is 2. Its low is 2 is 2 up and 1 to the right, like that. And this is also solid line. Yes or no?
Yes, sir.
Okay. Okay, approximately. And this is the line. Solid also, right? Because it's equal. Entonces look, is the region que is located is below, no? It's below because it's y, when I isolate y, is less than minus x plus 60, less than. Entonces below this line, below, and above this line. Entonces basically, my solution, my constraint solution is this. Okay? Yeah, I solving the constraint part. Now, what happened with the objective function? Okay, it's the most important part. One of the objective function, okay, I suppose it's a line. Exactly, I don't know what line it is. Maybe one line like that. I don't know. After in this one, I want to show you exactly what line it is. But I need to maximize, but inside the constraint. Inside the constraint, so when this line is in that part, okay, we have one piece inside, no? But it's maximum or minimum, depending, it's only in the corner of this polygon. Okay, look, we have 3 vertices. This vertex is 20,40. Look, do you see graphically? 20, 40. This is 0, 0. And this is 0,60, no? And you evaluate now the objective function and this point. Suppose C, evaluate 0, 0. Here's this guy. Well, it's obvious que es 0, no? Because 250 times 0 plus 150 times 0 is 0. Suppose Z evaluate in the second point que I select 2040. Well, the computation is 250 multiplication by 20 plus 150. Here's this number, multiplication by 40. No? I put it in my calculator, and the answer is 11,000. Okay, and C, evaluate in the last point, get 0,60. Is 250 times 0 plus 150 times 60. And the answer is 9,000. Okay, entonces now I try to select the maximum, and the maximum is obvious que es this. So what is the answer? Well, the answer is C is maximum. C maximum is 11,000. And this happens at X equals 20 and Y equals 40. Okay, this is a classical example of the linear programming. Let me show you geometrically the idea. In Desmos, in 1 second I show you. Look. Okay, switching. Carajo. Linear programming. Example 1. Okay, look at that. Okay, look. Desmos. Do you see Desmos now? Look. This is the solution. Look. Okay, I declare the inequality x greater than or equal to 0, y greater than or equal to 0, x plus y less than or equal to 60, and y greater than 2x. And the intersecting point, you find the corner of the polygon solution. And here, using this slider, we have the objective function. Look, the objective function, I have no idea, but I need to move here inside the constraint region and to maximize, to find what is the maximum, what is the minimum. Huh? In this case, the maximum is the good. Okay, maximum was 11,000. Look, exactly in this point was 11,000. Look at that, 11,000. And another point is, for example, in this point is 0,60 is 20,000. No good. And the other is 0. It's not good. So the maximum is in 20,40. Okay, so next time I will try to make a word problem that we solving using linear programming. Okay? 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 And this is the last part. And we start review. Please, everyone, try to print out the review. Okay, try to print out the review. To follow me quickly, because we are doing fast the review, no? Okay. Okay, guys?
Thank you, sir. Thank you, sir.
Okay, let me put it off.